Hello friends, welcome to my YouTube channel. Today we'll see Hadoop. As this particular Mahout shows that Hadoop is one of the biggest thing and which supports, Hadoop is one of the technology which supports big data analytics. It is the only tool that supports big data. What exactly is Hadoop? Hadoop is an open source software project that enables distribution processing at large dataset across clusters. This is very important when I'm talking about clusters. Clusters is ultimately it is nodes that we have seen in distributed databases. It is designed to scale up. It is again very important. It is designed to scale up from single server to thousands of machines with a very high degree of fault tolerance. Hadoop enables computing solution like scalable, cost effective, flexible and fault tolerance. Scalable means we can add as many number of servers which is needed, as well as we can add as many as clusters which are needed for processing of data. It is one of the cost effective because it is actually having what we won't require a big kinds of machines. We can simply use commodity servers, as well as we can use some clusters available easily with the other members. It is very flexible and having great features like fault tolerance. Products developed by vendors, actually there are many products. I have highlighted few. Very first one is Apache Origin, then Cloudera, Hortonworks and Intel. All these are the members which are actually providing us the Hadoop development. Now regarding the Hadoop has core components. There are various components of the Hadoop, but there are core component, and these are ultimately HDFS, that is Hadoop Distributed File System. HDFS stands for Hadoop Distributed File System. It is responsible to store data in chunks. Chunks here we can able to distribute our data, means we can decompose our data into smaller chunks, and that chunks will be stored into different machines or clusters for the further processing. Second important component of Hadoop is MapReduce. MapReduce, as there are basically two names, one is map, another one is reduce. So MapReduce will tell us that it is basically a processing element of Hadoop, where the data will be processed in a parallel fashion. So here map indicates that we can able to map. It has some functions like sorting, and in case of reduce we can able to finalize the result. So we'll see in depth what exactly is the map and the reduce. So let's move further about the in-depth knowledge of HDFS. So let's focus on HDFS. This is again very important that I have already told you. HDFS stands for Hadoop Distributed File System. So let's focus on what exactly Hadoop has. HDFS has. HDFS is one of the daemons, and when I'm talking about, it is one of the component, and it contains basically three important part. First one is name node, then secondary name node, then data node. Here name node is important concept, okay, and data node is actually part of name node. Secondary name node is actually backup copy of name node. So this we need to understand. So let's look at on in-depth knowledge of each and every part. HDFS, if we have overall overview of it, you can understand the structure is like this. With this structure you can understand here there are basically, it is a name node and it is backup node. It indicates that it is secondary name node. So name node is actually divided into various data nodes. So data node 1, data node 2, data node 3, likewise with various data node it has. And with this, the data is actually what data, the terminology that I have already told you, data is divided into what different chunks. So name node with the help of name node, we can able to divide this name node into various data nodes, and these data nodes will be further processed. Now, if you observe the HDFS block diagram, you can understand with this, it has name node that I have already shown to you, this name node and various data nodes. Now, with this data nodes, what will happen, and there will be one more part, that is secondary name node, that is ultimately known as backup name node. So, what HDFS will do here, whenever there will be any sort of chunks that we are getting, for example, you can understand it very well. You can understand it very well when I'm showing this particular part with you. Okay, so what will happen, with this node, basically there will be possibility that we can able to assign all the chunks to data node. So here there will be one chunk. Here again, that one chunk can be, its copy can be made. Again, the copy of a chunk can be made. There may be possibility that another chunk is available here and its copy is available here, its copy is available here. There may be possibility that chunk 3 will be available here, its copy will be available here, and its copy will be available here. So likewise, chunk 4 will be stored here and its copy will be available here as well as it will be available here. So likewise, the entire name node, okay, it is divided into different data nodes, and these data nodes will be further processed in case of MapReduce. So this we need to understand from this. Now regarding HDFS, there are various features of HDFS. It is actually having large data sets. It supports a big data, and that is the reason it supports large data. It has facility of write once and read many. We can able to streaming data access, that is possible. Streaming, the way we have seen that YouTube is live video streaming site, so that kind of access is possible. Commodity hardware can be useful. It actually supports commodity hardware. Okay, then it has its own file system. There is moving computation. It has very higher speed as far as computation is concerned, and that is the reason it has high throughput. Data replication facility is available. Before this particular slide, I have already shown you how we can able to replicate the data. We must know the factor of replication. Now here you can understand the meaning of replication that I was trying to show you. Now you need to understand from this that here it is replication like 3 and the size of block is 64 MB. There are various, these are the chunks. Whatever which is shown to you are the chunks. All these chunks will be distributed, okay, it will be distributed to various data nodes, okay, and further processing will be possible. So let's look at the replication factor itself is 3, so that you will understand. See that chunk 1 is allotted to data node 1 and its copy is available at data node 2 as well as data node 3. Okay, as replication factor is 3, so we are only representing it 3 times. Any data chunk will be represented 3 times. Now data node 2 is allotted to the chunk 2 is allotted to data node 2 and its replicated copy will be allotted to node 3 as well as node 4. Then chunk 3 will be allotted to node 3 and then its replicated copy will be available at node 4 and node 5. Then node 4, for the node 4 you can understand that node 4 is allocated to data node 1 and its copy will be available at data node 2 as well as data node 5. Then chunk 5 is again allotted to data node 1 and its copy are available at data node 4 as well as data node 5. So this way you can understand here all these chunks are actually divided into various sites, and finally processing of this particular elements will be possible, or all this particular data will be possible using MapReduce. So this is what the replication. Now regarding HDFS, where we have seen about name node, we can also focus on what the details of name node. Name node is also known as master node. It contains information about file location. Then it also contains the information about ownership of the file. It also contains the individual block and location of each and every block. Block is ultimately chunk in our case. Metadata is stored in the disk and read when name node daemon starts. This is normally known as FS image. So that is known as file system. FS stands for file system image. So this will be read and it will be treated as metadata. Then when the changes to the metadata are required, these are made into RAM. So RAM will play the great role, and the size of RAM will definitely one of the limiting factor. Changes are written to the log file on the disk called edits. So this way we can see that name node actually contains this important information that is very important, and this is what the role of name node. Now the next part. Similarly, secondary name node, that I have already told you that it is ultimately backup copy of name node. So it is similar to your name node. Whenever any failure will occur, whenever any failure, suppose this name node is failed, in that case this backup copy will help us to continue, and that is the reason there is need of secondary name node. Now the concept of data node. Data node is known as slave node. So I have already told you regarding master node, okay, and these are the slave node. Master will actually what run, and slave will be follower. So it actually contains what the data, okay, into what slave node. Blocks are simply files on the slave node's underlying system. So you need to understand that it will be having name, it will be having what the name block, okay, and nothing on the node provides information about what underlying file block is a part of that particular part. You need to understand here it has actually 3 replicas that I have already shown you, okay, and in one of the diagram I have already cleared you about what is the role of name node. With the example I'll clear you the role of name node as well as the slave as well as the master node. So heartbeats is one of the important concept here, as we all are aware that heartbeats in human body is one of the important factor. Similarly, data node and name node both are connected to each other, because at every 3 seconds heartbeat signal is sent from data node to name node, and that indicates that upon receiving that name node heartbeat signal to name node understand that the data node is actually connected. So that's the beauty of heartbeats. Now regarding the MapReduce. MapReduce is again very important concept. Map and reduce has actually MapReduce is actually basically it has 2 words, okay. Very first one is map, another one is what, reduce. So let's look at on in-depth knowledge of map and reduce. MapReduce is again the second important component like HDFC in case of your Hadoop system. Let's move towards what exactly is MapReduce. So MapReduce is the method of distributing a task across multiple nodes. Okay, we can able to distribute the task to multiple nodes, and then every node will work on this particular phase. First it will map, and then it will what, reduce. In between map and reduce there will be what, the operations like shuffle and sort. Okay, so we need to understand what exactly map is doing and what exactly reduce is doing. So with this example MapReduce, you will have an idea what exactly can be done. There is what we have done in case of HDFS, we have actually splitted this chunk. So chunk 1, chunk 2, chunk 3 is available, and we are mapping this chunk to some operations. So mapping is done here. Okay, mapping is done here, and once mapping is done, then here sorting or shuffling will be possible, and after sorting and shuffling which is done, then here we are doing, means if you observe this particular part, this is ultimately we are doing what, reducing. So if you remember, suppose we are actually talking about the playing cards, okay, and we have to sort all the playing cards. What will happen, split 0 can be our I'll give you what, all hearts to what, one of the students, okay, then diamonds to another student. So likewise we'll divide all the cards, and then that student has to sort that cards. So one student will take care of sorting heart cards, another student will take care of what, sorting diamond cards, and finally all these cards will be merged by using reduce, and finally we'll get the outcome. Friends, let's understand the use of HDFS and MapReduce with the help of this classical example. Here you need to understand the meaning of this particular program. A sample input is given here, then intermediate data is produced here. Finally, input to reducer is given here, and you will get what? The output from the reducer. So let's look at one by one to understand the actual use of mapper, that is map, and reducer, that is reduce. So this is what the program, sample program, which is given to you. Okay, the cat sat on the mat, the Arwak sat on the sofa. So here you can understand that the task here is that we need to count, okay, we need to count occurrences of each and every word. For example, you can understand that sat, okay, this is the word coming twice. So I can say that at sat, in front of sat, I'll write down 2. the, okay, it is available at 1 second and the third. So I can write down that the is coming for what? 3 times. So likewise, we need to identify the word count from this particular code. So what will happen to intermediate data producer? We will what? Tokenize each and every element. So what map will do? Map will tokenize each and every element, okay, and you can understand that the came first, then first, then first. So likewise, it is simply separated, and this particular job will be assigned to whom? This particular job will be assigned to reducer. Now what reducer will do? Reducer will perform like how many times what is coming. The way you have seen that it is coming only once, cat is coming only once, mat is coming only once, on is coming twice, so it has written like 1 comma 1. Same like sat, sofa is also coming 1, but the is coming what? 4 times. So from this you can understand that, and at the end of this particular reducer, what reducer will do? It will simply sum each and every number, and that will be the output from what? The reducer. Now you can understand that it is 1, it is 2, it is 2, and it is what? 4. So likewise, map will assign the task and reducer will finally perform the operation that we want of what? Summation. So that's the beauty of map and reduce. So this entire thing is actually mapped using one of the diagram. You can understand here, suppose there is deer, beer, river, and we need to again what? Count this, how many times, okay, how many times, like again word count is one of the program that we need to do. So what we are doing, we are giving first line to this, okay, we are giving what? First line to this, second line to this, and third line to this. So we have splitted this entire 3 lines into 3 different lines. Then again these 3 lines are mapped to different systems. So it is mapped to this, it is mapped to this, it is mapped to this. Okay, finally in case of shuffling, what is happening? It is collecting for the information of beer, it is collecting information for the car, it is collecting information for the deer, it is collecting information for the river, and finally it is reduced by simply sum up the bear, like the count of bear, it is what? 2, the count of car is 3, the count of deer is what? 2, likewise the count of river is 2, and finally you are getting what? The outcome, and this final result is possible due to the process like mapping and the process like reducing. So this is known as map and reduce process. Here you can understand that this particular data structure, you can understand this is the function, okay, it takes an input, okay, it takes an input and produce the output like this. Reduce, it takes an input and produce the output like this. So you need to understand, in case of map we simply need key and value pair. In case of reduce, we need key and list of values. For one key there will be different set of values, and finally the outcome will be produced in the form of again key and value pair. So dear friends, I have already told you regarding key value pair. Here key value pair is used in both the functions like map and reduce. Always remember, map and reduce is programming environment of what? Hadoop. Again, you can understand from this particular path the overall map reduce count process. So this particular process will give us what? The final result, and that is what I have already told you about this. The role of mapping and the role of reducing is important. So what we are doing in mapping, we are simply what? We are simply separating each and everything, Okay, and in case of reducing, we are simply sum up each and everything and we are displaying it. So we need to write down two different programs, one for mapping and another one is for reducing. So this is all about map and reduce. So my dear students, big data and Hadoop has great opportunities. So you can go with any sector like business or analytics or intelligence. It is really very important area. Okay, so I hope you all will enjoy the session and you all can able to work out. If you have any doubt, any question, please post it on our Google Classroom. This is all from my end, my dear students, my dear friends, and today we are completing all our 6 units. Thank you so much for your patience listening.